Number 6. The calculation performed in the chaos program can be written in a number of ways that are algebraically equivalent. Write a version of the program for each of the following ways of doing the computation. Have your modified programs print out 100 iterations of the function and compare the results when run on the same input. Okay, so we're going to do 100 iterations of the function. So let's keep this exact program, but as the user, we're going to punch in 100 here. And we're going to look at A, B, and C, explain the results of this experiment. Hint, see discussion question number 4 above, which modifies the chaos program so that it prints out 20 values instead of 10. Okay, so, well, the 100, so I guess here, N, let's just do 100 here. We can make that just a comment. We'll probably delete this as far as turning it in. We'll probably delete that line as far as turning it in. But for right now, we can just put that there. So now it's just a comment. And let's do A. So 3.9 times x times 1 minus x. So we'll go back to the initial. 3.9 times x times 1 minus x. Double check. Okay. So let's save as. Make sure it's in the Python folder. Yeah, it's saving them there now instead of the desktop. Okay, cool. So now let's go here. Nope, we don't want to go there. Actually, let's just cancel this. I don't want to delete it. Okay. Now, let's go to open. Now we're going to go to Python. Open chaos.py. And so this is our program. Make sure it's right. 3.9, 100. Okay, cool. Let's run it. Run module. All right, this is a lot, so we're going to go 0.12. This is a bunch. So 100 times, ladies and gentlemen. Totally random. Or at least it's been somewhat randomized. It feels totally random. It's chaos. It's called chaos. It's a chaotic function, so it feels totally random. I'm sure some mathematicians can figure out if it's not totally random or that it's not totally random. But it looks pretty random. Fairly random. Would be my argument. It looks fairly random. Okay, so now let's compare the results when we run on the same input. Okay, so now let's open up this. So now let's do B. So this is going to be times. Now all we're doing, well, here we're actually changing the 1 to x. So this is going to be x minus x times x. So remember, it's not going to be 0 times x, which is just 0, which makes this 0. It's not going to be just 0, 0, 0, 0, 0, right? It's PEMDAS, right? From math. Please excuse my dear Aunt Sally. It's going to be, we're going to do multiplication first. Now, obviously, Python might have 1 or 2 little intricacies, which we're going to learn about through John Zelle's book. But, yeah, as far as, so we're going to multiply them first, and then have x subtract them. Subtract that. So it might even be a negative. So this might be a negative. That's my analysis. Potentially, these could be negatives. But maybe not, because these are going to be decimals, right? Yeah, so if a decimal multiplies by a decimal, does it become smaller or bigger? It's going to become smaller, right? So 0.3 times 0.3 is 0.09, right? So 1/3 times 1/3. Yeah, let's just do it. Let's just do it in fraction form. Like, so just think conceptually, fraction form. 1/3 times 1/3 is 1/9. So a fraction, so a decimal times itself is a smaller decimal. It's closer to 0, without going to the negative. So
So it's going to be, so then you take x and subtract that, you still have a positive number. Then 3.9 times that, you still have a positive number. So they're all going to be positive. But anyways, these are just things to think about. You know, I know it's important to just focus on, focusing on Python and each one, but you also want to think a little bit about back to your math a little bit. Think about, I think it can't hurt. It keeps you in that sort of back end programming like mathy mind. It keeps your brain working, and I'm a huge proponent of that. Just like thinking through things that might not directly connect, but that it's just you're just curious. You're like, oh, I wonder. I forgot this. I don't remember if 1/3 times 1/3 is going to be a smaller fraction or a bigger fraction. I know a small integer, small positive integer times another small positive integer is always going to be a bigger integer, right? 2 times 3 is 6. It's never going to be less than 2 or 3. But when it comes to fractions, it works the other way. So just I don't know, just things to think about. It keeps your brain busy. But okay. So anyways, now let's go back here. Okay, so let's go to let's go back there. Let's do it again. So now we're gonna go to we're gonna go to okay, here we go. The program, right? This is the output. This is the shell. This is the program. So now we're gonna run it. We have to be in the program to run the program. Okay, we're not gonna run it. Why aren't we gonna run it? Well, because this is showing the last run. How we set it up there. Okay, so now we're gonna open a new one. So open, and then now the default in Mac as it sends us here. Now, if we keep opening that one, if we keep opening that file in that folder, then it helps us out a little bit. Okay, so I don't know. I think we messed it up. Let's see. I'm gonna X this out. Now we're gonna go X this out. Now we're gonna go open. This should have saved it. I think I saved it in a Python folder. Let's go to chaos. There it is. Okay, cool. So yeah, this is why you gotta go slowly. And when I say you, I mean me. But it's really helpful. Like, even if you're used to just flying through stuff, and if stuff's really easy, like when it comes to computer stuff, like you wanna just be patient, and double check folders, and learn how to use, like just spend time with your computer, like lots and lots and lots of time with your computer, because you're gonna make rookie mistakes. You're gonna like open the wrong folder, and it's gonna frustrate you if you don't really get to know your computer, like how to use it, how it works, like how it thinks. Like, does it, if you keep reopening the same folder, does it automatically go there, like eventually, or does it keep going to a default? Can you set it up? Obviously, you can program anything, right? So you can program it, or you can find programs, that work where you can set up certain defaults, but you just want to think about the default functionality of your computer, and so that's why I always recommend just spending a lot of time getting to know your computer or your computers, as well as the program that you're using, etc. Okay, so, and the version, right? We're using Python 3, so it's very different than Python 2. Python 2, the eval function doesn't work. It's so you're gonna get frustrated. So you've got to know, if you're in the right folder and using the right version and all of that stuff. So that's all right. So let's run this again. All right, so let's try 0.12 this time. It's pretty random to me. Looks very random. Extremely random. Again. Remember, we're not using 2.0. So unless it's a, misprint as far as 3.9, it looks random to me. 8.847, 0.5, 0.97, 0.9. And it's very rare that you're going to see misprints. It is possible, but very rare. We also have the errata section on John Zelle's website. So we're gonna go over that as well. All right, so let's run this. Let's run this again. So 3.9 times x minus 3.9. And it's key to like keep the spacing. I mean, just obviously try to copy what he's got here. But just good practices, readability. 3.9 times x minus 3.9 times x times x. Double check. That dot's gone, so we know it's been saved. We're gonna go here. Now it opens up both, which is great, right? Now that we click here, idle, it opens up both. All right. So now we'll click here, and we'll go to run module. 0.64. Let us see. Again, it seems really random. Really random. I don't see a lot of repeat numbers. It's kind of fun though. I mean, my brain is working like, oh, this, it starts with this, but it gets to these fun apps and websites and applications and hardware and stuff. I mean, it's just software. It's just really cool. It's really cool. This is a good first chapter because it's showing you this is what computers were designed for. To do these things that it would take a normal human being a lot longer to perform. So it just gets you in that computer science mode and that, and thinking, what are computers best doing? And yeah, so this when I run on the same input, okay, so now it says have your modified programs print out 100 iterations of the function and compare the results when run on the same input. Okay, so what we want to do is we want to run on the same input. So let's go back to 0.8, 0.22, 0.12. So let's just do 0.8. So go back here, run it again. And let's see. So 0.8. Let's see. So I would let it print out. As long as it's not an infinite loop, we're going to X out of it. I would let it print out and then go look and see where 0.8 sits. So again, this looks very random. Okay. So this is going to be, all right, so 0.8 right here. This was our original for 3.9, totally random, right? Less than 1, they're all going to be less. All of them have ended up less than 1. You notice that, right? That's a pattern. Just seems similar to me in the sense of totally random. It does go to, it seems like it goes, yeah, it seems really random. There are a lot of 9s though, 0.9, 0.9, but it still seems pretty random. I would say random. Explain the results of this experiment. I would say random. Doesn't seem like anything crazy happened. If I'm wrong, please correct me at the bottom. I didn't use any like answer manual. So yeah, I know that John Zelle does have some answers on his website, and there's probably some running around. I saw some on GitHub, but it just seemed like there wasn't any a resource that had them thoroughly, like all the answers thoroughly explained. So I wanted to create it. Anyways, I think that it's pretty random for number 6.